going to be doing another section of area, but we're going to be doing area and perimeter of similar shapes. What the shape is really does not matter. It doesn't change at all what we do. So, area and perimeter of similar shapes. And again, it does not matter what the shape is. It does not change what we do at all here. Okay, so I want you to form a hypothesis. If I have, say, a square, and let's give it a length. Let's say it's 3. Now, if it's a square, what do I know about all these lengths?
Equal.
They are all the same, so they are all 3. And, of course, all squares are similar, so I'm going to have another square. And for this square, I'm going to get all of them are 6 inches. I want you to form a hypothesis. So, my hypothesis. That's your guess. Here's the sentence. Finish the sentence. If I double the size, then the area blank. Form your own hypothesis. Also, then the perimeter. So I'm comparing the new area and new perimeter to the original shape. So this is my original, and this is my new shape. You form a hypothesis. If I double the size, so I doubled the scale, right? My scale is doubled, like this. The ratio here is 1 to 2, right? So if I double this shape, you form your own hypothesis here. We're going to test it using, we'll just use this shape as an example. Okay? Don't worry if your guess is wrong. And then we'll actually find the area and perimeter. So what's the perimeter of the first shape?
No, 12.
12. And what's the area of the first shape?
9.
Okay? And what's the perimeter of the new shape?
24.
And what's the area of the new shape?
36.
Okay, let's 36, sorry. Okay. What did you write for area?
Quadruples.
Is that what you wrote? Quadruples?
Yeah. Same.
Who wrote something else?
Quadruples.
I put doubles.
Did it double?
No.
No. Okay. What did you say for perimeter?
Double.
Doubles.
Doubles? Okay. So,
What?
did it quadruple the area? Yeah, it was times 4. It didn't double it, though, did it? It quadrupled it. Okay, now we're going to have to generalize this a little bit more. Suppose I start with my same square. And that's going to be similar to this next one. What if I multiply all the sides by 3? Let's say I triple its size. Make a hypothesis. What happens to the area and perimeter? Take a guess. So if I triple its size, I get 9s here. Okay? Give me some of your thoughts. What do you think about the area, Evan? What happens to the area?
It gets bigger.
Okay, give me a more specific answer. Alright, someone who's willing to give a more specific answer. Actually form a hypothesis. I don't care if it's wrong or not. I want you to take a guess.
It quadruples.
Okay, I have a guess that it quadruples again. Okay, someone else, give me an actual hypothesis.
8 tuples. Maybe it goes by 8.
Okay, triples. Someone else give me a guess.
Maybe it does, yeah. 9 times.
9 times
I was
bigger.
trying to think of a word for that.
Yeah.
Or maybe it times is by 8. Quadruple, double.
Okay, let's see. What's our perimeter of the first shape? It's still 12. Okay, what's the area of it?
9.
Still 9. Okay, what's the perimeter of the second shape?
81.
36.
Sorry, 36.
What's the area?
81.
81. So it's 9 times bigger. Okay, so let's see here. When I doubled the size, when I doubled it, okay, I need you following along and writing this down for those of you who are checking out. And when I tripled, let's see what happened. So I doubled, that would mean times 2, so my ratio was a half for my size, or 1 to 2. And when I took a look at the areas, quadrupled, so the ratio was 1 to 4. And when I tripled, my ratio was 1 to 3, because I tripled the sides. But then I ended up with 1 to 9. Okay, let's see if we can generalize that. Take a look at my ratio here. What happened? I heard it. It was squared. That's what happens. So let's see if we can look at that in more general terms. Let's say if I have my square and my sides are x, okay, and then I size it by any scale, ax. Now to get area, what do I do?
Base times height.
Base times height, right? So the area here would be x squared. Well, take a look at this. To do the base times height here, my area would be ax times ax, which from algebra class gives me
A squared,
x squared. So notice my scale is squared. And that's going to hold true for any scaling that I do. So we're going to form a chart. And actually we're going to make this chart a little bit bigger than what we need for this chapter. We're going to extend it into volume because it's going to be the same thing. What do you think? For those of you who are right with me on this, what if I talked about a cube?
So maybe you cube it.
Yes, it would be cubed. Because I would be multiplying a an extra time, right?
Right.
So that'd be volume. So here's our chart. I'm going to have ratio of the sides, ratio of the perimeters, ratio of the areas. Okay, so ratio of my sides, ratio of the areas, ratio of the perimeters. Okay, let's get a table here and add in ratio of the volumes. We aren't going to do volume yet, but this way we get a little jump start on the concept. So, I take my ratio of the sides, and that's going to be whatever. Whatever our scale is. The ratio of the parameters equals the ratio of the sides. Okay, let's back up to see that. So, see, what's the ratio of these sides? 3 to 9, right? 3 to 9, which reduces to what?
1/3.
1/3. Okay, let's take the perimeters. 12 and 36.
1/3.
12 over 36 reduces to
1/3.
1/3. Okay, so the ratio of the parameters equals the ratio of the sides, whatever that happens to be. The ratio of the areas is going to equal the ratio of the sides, but
Weird.
squared. And we just talked about volume. Ratio of the volumes is going to be ratio of the sides cubed. Why? Because it's a cubic measure. We're counting the number of cubes. Y squared for area, because we're counting the number of squares in a shape. In perimeter, well, that has to deal with the sides anyway. So here's what we're going to do. Now, you can do this for any shape, okay? So we're going to use blobs that we know nothing about, okay? So here's blob number 1, and we're going to say that that's similar to blob number 2, okay? Those are the same shape, okay? And we'll say that this distance here on this shape is 5, and we'll say this distance right here, let's say that is 15, and let's say the area of this shape is 20, and I want to know the area of this shape. Now, I don't have an area formula for this blob, okay? I'm just told what the area is. I'm going to have to use this concept of ratios in order to figure it out. So, the ratio of the areas equals what?
Ratio of the sides squared.
Ratio of the sides, but squared.
So it would be 1/3 squared.
So, the ratio of the sides would be 5 to 15, right?
Squared.
Squared, but I'm going to want to reduce that to 1/3 squared, which is 1/9. Now, this is half the work, okay? I have my ratio, but the area of this thing is not 9. So I'm going to do a comparison. I'm going to compare. I generally want to always, I just want to be consistent. I'm always going to compare the first shape to the second shape. You can do small to big or big to small as long as you're consistent. So I'm going to compare the first to the second. Whatever that is, whether it's bigger or smaller. So I'm going to say the area of the first shape compared to the area of the second shape must be in the ratio 1 to 9. First shape, second shape. You with me?
Yeah.
Now, how do we solve a proportion?
Cross multiply.
Cross multiply. So area number 2 is
180.
180 units squared, whatever that happens to be. Now, what about the parameters? Now, I didn't tell you the parameter of this shape. Let's say the parameter of this shape is 30. Well, the ratio of the parameters is equal to the ratio of the sides. So then all I have to do, if I want the new parameter, the first parameter is 30 compared to the parameter of the second shape. The ratio of the sides is 1/3. Again, cross multiplying, the parameter of this second blob is 90 then. Alright, let's do another, just to kind of emphasize this point. So let's say I have, just so that you don't freak out when you have a triangle, okay?
You know what's too late.
Well, no, it's triangles, because we've never seen them before.
Oh.
Okay, let's say this is 3, and, let's say this is 12. Okay? I've only given you one dimension, right? I haven't given you enough to actually find the area of these things. So let's make up an area for this first shape.
20.
Okay, and we want to know the area of this one right here. Okay? I need to find first. What am I going to do first?
Need to find the
ratio.
Yep.
Ratio of the sides. Okay, even if we were doing volume, that's the first thing we're going to do is we want to know the ratio of the sides. So it's going to be 3 to
12.
and then I'm going to reduce it to 1/4. You don't have to reduce it, but you make your life a lot easier. The second thing,
is to square it.
square the ratio.
1/16.
Okay, so 1/4 squared is 1/16. This gives me the ratio of the what?
The ratio.
Ratio of the sides.
Ratio of the areas.
Oh, sorry.
This is what?
The ratio of the sides.
That's ratio of the sides. Alright, so I know that my scale here is 1/16. So 1/16. Now I'm going to set up the third step is a proportion.
120.
Okay, so we're going to set up a proportion. So my first shape was 20. My area of my second shape is, what do I do?
Cross multiply.
320.
Cross multiply. So area 2 is
320.
320 units squared, whatever those units happen to be. Does anyone need to see another example of that? Pop your hand up, it's okay. Yes.
Why, when
What?
you square, when you use 1/4 times, why is it 1/16?
1 squared is,
1.
4 squared is.
16, but it's smaller. Why does it
I'm
get
going
smaller?
from this triangle to this triangle. So this area should be much bigger. But not 4 times bigger, 16 times bigger.
Okay.
See, imagine it, see, you might want to do like 1, and you can put a colon 16. It's the same thing.
Okay.
It's the same thing as 1 over 16.
Yeah, exactly.
Okay, so does anyone need to see another example of doing this?
No, but I need to wake
One more.
up.
Okay, so,
got you.
okay,
Eat it, dumb nut.
here is a student's face. We're a bunch of head shrinkers, so we shrunk their face. Okay,
Yeah, my head's
so
probably shrinking.
let's quiet down. Let's say the area of this first face is 50. And let's say the height of this face is, I don't know, sure, 5. And let's say
3.
Okay, sure. The new one's 3, and I want to know the area of this face. Okay, so the first thing I need to do is find the ratio of what?
The size.
Okay?
So 5.
Daniel is muted. So ratio of the sides is
5 over 3.
5 to 3. Now I need to get the ratio of the areas. So what do I do with my ratio of the sides?
Square it.
That's going to give me 25 over.
15.
Careful, what's 3 squared? 9, not 15. So 5 squared is 25, 3 squared is 9. Now I set up a proportion.
Yes.
So area of the first shape.
over a to the second, and then that would be 25 over 9.
Okay.
Wouldn't it be?
Now, or a2, it's not a squared. It's the same. So I cross multiply.
Correct.
Okay, so I get 25 times my other area equals 50
450.
times 9, so that's 450. And then I divide both sides
18.
by 25 and get
18.
18. So the area of this face is 18 units squared. Yes, okay.
You divided what?
At this step, when I cross multiplied, I got 25 times A and 50 times 450. In order to solve for A, I divide both sides by 25.
Okay.
Okay, we have one more example, and then you're doing a bunch of work. Okay?
It's just, he just pushes A.
Pay attention.
It doesn't matter.
You should be copying this down.
Baseball field.
Maybe that's what it looks like. I don't know. It is. Good.
Okay? Seems to be a corner of something. This time, instead of finding the area, okay, I am finding one of the sides. So now, I need to go a little bit backwards. I don't know the ratio of the sides, but I will know the ratio of the areas. Okay? And I purposely made this one harder. Okay. So, I know the ratio of the areas. What's the ratio of the areas?
60 around.
60 over 100, which I might want to reduce to,
3 over 5.
Why can't you just like double it?
no, it's not double, and that's why we did the thing at the beginning, where I showed you why it's not double.
I know.
Okay. Now, let's think for a moment. Let's say that the ratio of the sides was 3 to 4. Let's say it was that. How do I get the ratio of the areas?
You double it. I mean, you square it. Not
I
double it.
square it, not double it. Square it. How do I get the ratio of the areas?
Square it.
9 over 16. Now, let's think. Let's say I started here. How would I go
Square
back?
root.
It'd be a root. So what do I have to do to this?
Root 3. And
So
then
the ratio of the sides is going to be root 3 over
root 5.
root 5. Now sometimes that comes out nice, and sometimes it doesn't.
Let's see.
So don't freak out if it doesn't.
Don't we need to rationalize now?
We don't need to bother with that.
Okay.
So I'm going to set up my proportion. I do not need to bother with rationalizing because I just care what the ratio is, and that's all I care about.
Okay.
So 8 is to what?
X.
X, as root 3 is to
Root 5.
root 5. I cross multiply, I get 8 root 5 equals x root 3. Now how do I solve for x?
You divide by root 3.
So x equals 8 root 5 divided by root 3. We don't need to freak out, we just put this in our calculator.
10.3.
This is like
Mr.
math
Kane,
potluck. It's just
Okay.
everything thrown together.
so I didn't know that you were going to do it that way. So I did 3 over 5 equals, and I squared the 8 and x, and I got the same answer as you did. Coincidence or
I think not.
pure genius?
Coincidence.
So you did 64 over x squared because the ratio of your sides squared should equal the ratio of your areas.
Yeah, I did.
That is fine.
No, I did 60 over 108 over x.
Yes, that makes
Okay.
sense because the ratio of your areas would be 60 over 100. The ratio of your sides it would have to be then, if we compare that, 64 to x squared. Then we would cross multiply. You get 60x squared equals 6,400.
And then you get 106.667, and then you would square root that, and you get 10.3.
Yes, that's fine.
You're
That's
not
what
existing
you
as
did.
a coincidence.
Because sometimes you're going to be asked for the ratio of the areas and ratio of the sides, in which
True.
case you don't get that.
In every case.
But that's fine. Let's try one more, and then you're doing a bunch of these on your own. So we have blob.
Why are we drawing blobs?
That way you can't use an area formula.
So you're trying to make it hard.
Yes.
I just want you to use the concept that I'm teaching you,
Okay.
as opposed to try to do it with an area formula.
Right.
Which if you know what the shape is and know the area formula, you can do that.
It'd be much easier.
Is there an area formula for blob?
Yeah, blob root 1.
You had that.
Guys, would you like to have extra homework?
No, sir.
Or would we like to focus on what we're supposed to be doing?
Like to
Supposed to,
focus.
sir.
Okay, so I want to find the missing side. Let's do it Jacob's way, because that's fine. Alright, so the ratio of my areas is what? 10 over 15. Okay, and I can reduce that to 2/3. That's fine. Okay, now, my sides are 4 to x. What Jacob is saying is, well, according to our process, if I square that, I get the ratio of my areas.
Yep.
Okay? Is everyone with me?
See.
So okay, let's back up. Okay, were you with me on here, Victoria?
Yes.
Okay, so what we did when we did this is we found the ratio of our sides. We got 1/4, and then what did we do with it?
Squared it.
We squared it because that gave us the ratio of our areas. Okay? All we're saying up here is I start with my ratio of the areas.
And
It's
then
this.
square it.
So then we looked at our sides, 4 and x. Yes? We square that. Okay? These two ratios should be equal. So 2/3 should be equal to 16 over x squared. Cross multiply, 2x squared equals 48. Now what? Now what?
Divide by 2.
Divide by 2.
Hello?
Now what?
Square root it.
Square root it.
Square root 24.
So that's about what?
286.
4.9.
Yes, genius. Oh, never mind. I'll let you go.
Yikes, Kane.
Why is it 16 over x?
Okay.
Jacob.
Oh, never mind. I see.
I was like, I just talked about that. Now, if for some reason that completely confused you, let's do it the other way.
Okay.
I concur.
Okay, so our ratio of areas is what? What's the ratio of our areas? Follow along.
10 to 15.
10 over 15. Please pay attention, follow along. Now, we're going to reduce that. Reduce it.
2 to 4.
2 over 3. Is everyone with me? All I did was reduce that. Now, how do I get the ratio of the sides from this? Square root it. That's the ratio of the sides. So I'm trying to find my side. You with me?
Mm-hmm.
So what's the ratio of my sides? 4 to x equals, ratio of my sides is root 2 over root 3. Now what do I do?
Cross multiply.
4 root 3 equals root 2 in x, not root x. Root 2 in x. How do I solve for x?
Divide by root 2.
So 4 root 3 divided by root 2, that's calculator work. You get the same answer. All right, we are going to practice a bunch.
What was the same answer?
Bye-bye.
It's the same
Like
answer.
and subscribe.
Make sure to